remember in grade 10, I would have shown my classes like solving directly for x, okay? And so what we're going to do here is first complete the square and switch it from standard to vertex. And we do that via completing the square. Okay, so this question is nice. We can complete the square right off the bat here because the a value is 1. Okay, and what we're going to do is say the z value is going to be the b value divided by 2 squared. So it's 4 divided by 2 squared, which is 2 squared, 4. Okay. Anyone wildly blown away by that? Okay. Those first 3 terms. Okay, I keep doing this. You don't need to show me this, but the first 3 terms condense down into, that's a perfect square trinomial. 2 numbers that multiply to 4 and add to 4. That sounds like 2 and 2. So that condenses to x plus 2 squared. And then you have the minus 4, minus 11. I saw a bunch of minus 11s as people were just quickly handing that in. So that's good. Okay, that's a bare minimum, I'd say, if you need to be able to get it to this stage. Okay, so that's a vertex, right? Vertex is -2, -11. I saw a bunch of that as it was coming in, so that's positive. Okay. Saw kind of a mixed bag in terms of solving for the roots. So, okay, once you have this, okay, remember this is in the interest of producing the graph, right? So we need at minimum 3 points in order to produce a quadratic, I'd say. Okay, you found the vertex, that's 1. You'd know the y-intercept. What's the y-intercept of this one? Yeah, you'd have the y-intercept would be 0, -7. So there's 2 points, but that's not necessarily useful. I suppose you'd know the axis of symmetry. You'd be able to produce the graph using the axis of symmetry and the y-intercept, which is what? Which is what we did the other day with the partial factoring. That's partial factoring. You could solve for that other point that's in the axis of symmetry using partial factoring, and the y-intercept is 0, -7. Okay, but this question has specifically asked you for the roots. Okay, where does like the ball hit the ground or whatever? Okay, so what is true about all points along? Remember, another word is for roots is x-intercepts. What is true about x-intercepts? Y equals 0. So that also translates to f of x is equal to 0, because f of x is equal to y, if you need a reminder. Okay, so I'm going to set that equation in vertex form equal to 0. This one, not the original, because I know the original doesn't factor. That's not what we're doing. We're solving for the roots. Okay, I wouldn't, well, if I did give you a question that didn't have roots, it would be a trick question. But you should be able to identify that it doesn't have roots and confirm it. Just because something doesn't factor doesn't mean just because something doesn't factor doesn't mean you write no roots. You always have the quadratic equation at your disposal, which I think we can all agree is annoying, which is why this exists. Because I could just do this. 0 equals x plus 2 squared minus 11. Add 11 to both sides. Square root both sides to get rid of the squared. Add the plus minus. I get plus minus root 11 has to equal x plus 2. I'm okay with the roots looking like this. Especially if this is on the no calculator portion of the test. Done. Move on with your life. You don't want. We're just trying to give you alternatives to the things that I know and you hate from the past, like the quadratic equation. Nobody likes substituting things into the quadratic equation and doing like 6 lines of work to get at 2x intercepts. Can we all agree? I would rather do that process there than do the quadratic equation on the equation that doesn't factor. Can we all agree? It's about efficiency. Okay? Recognition of what to do when to get to the answer that's been asked of you in the fastest, most reliable way possible. That's what we're trying to show you. Okay? Now, just so that I can see whether or not you can complete the square on something a little tougher, I put question 2 on here. Okay? First things first, though, the coefficient in front of x squared must be 1. So let's do that. Everyone happy? -3 divided by -1/4 would be +12. There's the work. When we have fractions inside fractions, we would have multiplied by the reciprocal of the denominator. Okay? All right. Let's go. Now you can find a z value. Ooh, I forgot the bracket. Okay, so despite there being a fraction in this question, I actually think it worked out to be a nice vertex. All right, we get -1/4 x plus 6 squared. What's 1/4 of 36? Or 36 divided by 4?
9.
It's 9, right? This might actually have better roots than the other question. I don't know. I didn't ask you to do that. That's okay. You'd follow the exact same process. So you have a vertex of. Ooh, we'll have a different conversation with this question. I'll move it up a sec. Okay, we'll have a different conversation here. Because in your head, the same way I just thought about what was going on, if I asked you to solve for roots in this question, let's think about what's going to happen. Because I can ask you that, and some of you can just jump right into the, like, monkey see, monkey do game and just try and get an answer, right? But what's going to happen? Let's think about what's going on here. Owen, do you want to enlighten us? Let's draw a little sketch, right? Is that what you're thinking?
Yeah.
All right, let's think of that. Where's the vertex? -6, -3 is going to be over here somewhere. What is the direction of opening for this quadratic? Up or down? Why do you say down? That was a definitive down, so why say down? The A value is negative. which means the parabola looks, I don't care what it looks like, it looks something like this. Never going to have roots.